So we are just about to start the next session, session number 5. And I just would like to have your attention for a minute. So before we start the session, I just have one wish, and this is for those colleagues who will participate at the capacity training on Thursday and Friday. So you need access to the SDMX lab. And at the moment, we see that from the 140 people which participate on the first day, only 30 have actually registered for the SDMX lab. So in order to avoid a logistical nightmare on that day, can you please have a look in your emails and follow the instructions in your email to get access to the SDMX lab? If you have a problem with setting up your account there, in the coffee break, there is the HMS booth. You can go to the colleagues and you can ask for help there. But please try to spend some time now in order to get access, because tomorrow it's going to be a little bit hectic in the morning. All right? So this is for those people who attend the capacity training on Thursday, Friday. Please get your account for the SDMX lab. Thank you. And with this, I hand over to Olivier.
Thank you very much. We have this afternoon another very packed session. We have 8 presentations and we have 85 minutes for that. So we will try to be as efficient as the previous session. So I would ask all the presenters to stick to the 10 minutes and we have someone to keep us on track on this. So this session is about improving statistical business process using SDMX. In one of the side session or side meetings we had, someone mentioned that the X in SDMX should disappear. X, what was there because SDMX was basically a standard intended to facilitate the reporting by some agencies to some other agencies of statistical data. I think it's obvious to absolutely everyone that it is much, much more than that, and that the beauty of SDMX is now in every process of most organizations that have decided to use the SDMX. So what we're going to see this afternoon is another series of examples where SDMX has been embedded in different processes of quality control, of improving automation, making data ready, building better service for the users. So this is a very good continuation of all the nice examples we had so far today. So I'm not going to speak much today. I'm not going to try to summarize every presentation. They are very diverse. And I don't want to steal time from the presenters. So without further ado, we'll start with Sujesh Kumar from the Reserve Bank of India, who is going to make a presentation on a pilot initiative for element-based reporting in the Indian banking sector. So Sujesh, the floor is yours.
Thank you. Very good afternoon for all. First of all, let me express my sincere thanks to the organizers for this SDMX Global Conference. And I'm thanking the organizers for giving this opportunity, this platform to present our SDMX journey in the Indian banking sector. So let me start with the overview of the SDMX, or overview of the data management in the Reserve Bank, and what are the SDMS initiatives in the RBI, and the conversion tool what we have used for converting the traditional data into the XDMX data formats, and the XDMX collection initiatives. This is a pilot initiative. This basically I am focusing on this, and how we executed the pilot plan and what are the developments so far. So this is what I'm covering in my presentation. Let me come to the overview of our system. as a regulator of as a central bank of the country, as a regulator, we are regulating around 11,000 regulated entities across the country. And we have a specific template called the return. We call it as a return. This is a statistical format in which we collect the data. And this is something around the 240. And we collect different types of data like supervisory data, regulatory data, and payment system data, macroeconomic data, not only from the regulated entities, it is from the other organizations also. And survey, of course, surveys, statistics, we collect and disseminated this type of data. And we also use various channels of collection data. There is a system-to-system channel. This is fully automated channel. There is no manual intervention. And second one is the file upload channel and screen-based channel. This is another channel through which the entity can submit the data, because in Indian case, because the number of entities are more, the maturity, IT maturity is not similar to all the entities. So we are given different choices. Accordingly, they can submit the data. And we also maintaining our neighboring countries' SAC database. So all the macroeconomic data we are maintaining, so that even other country data also for the researchers and those who are using the data, they can download the data. This facility we are giving through our data portal. And very extensively we use the data based on Indian economy. This is the macro level data we disseminated through the system. It is called a DBI. It is well known in India because all the researchers, universities, all the data organizations, data of service providers, everybody using this data. And almost 1,000 plus reports we are releasing, around 2 lakh data series, and this sector-wide dissemination. And coming to the XDMX, we have started this journey for the last 3 years. In 2022, there was an internal committee set up by the Reserve Bank of India to how to reduce the reporting burden of the regulated entities. In that aspects, out of several recommendations, one of the recommendation was you should use the element, you should explore the element-based reporting, and it should be a future vehicle for the data collection from the regulated entities. Here the element, you should not be confused, the element is in the XDMX language, it is the DST. Basically, it's a DST. So we have started this journey in 2023, and we created the data elements based on the business purpose, because as I said, there are 243 returns currently, it is applicable. Currently banks are submitted. We examined all the data sheets and we identify the dimensions, code lists, everything we scored it, and it's such a laborious exercise because the 240 in each, the number of cells are much higher because we are collecting a large volume of data. So that exercise we have started, and we have created an element-based repository, and then we have developed a SDMX-based tool. This is a data query tool, so that everything is metadata driven, because we already defined the metadata for each and every dimension. It is so from that metadata hub, so anybody can query that facility. We are made available in the RBI portal. So this is some of the overview about our. This is just a flower of our. This is a cross-section view of the return. So we have defined around 1,100 DSDs. We have defined around 1,400 dimensions. We have defined this, and in the central we have SDMX manager, and we integrated with the Fusion metadata registry. And data query engine also we developed, and the converter tool, because we have to parallelly convert from the return-based information to the element-based data. This is one level of conversion. And we also developed a converter tool for the banks, because we need to fulfill certain prerequisites, because in the journey of SDMX, not only the data elements we ourselves created, but in the banking sector also they have to adopt our standards, because we define the standard for the SDMX, and we advise the bank, you also follow the same set of standards, so that they will also have to create kind of data repository that will be easy to communicate with us. So in the data query, there are different segment, the way we are disseminating the data in the database of Indian economy. This is a sector-wise, a corporate sector data, or financial sector data, and real sector data, public finance. These are the broad categories, so in which people can simply click and download the data. This is already available, but in the XDMX format also we have made available. You can simply you can plug and play around the dimensions and code list. Finally, we can even produce the beautiful charts and the different types of chart. We can combine multiple dimension, join graphs, all we can produce. And we integrated with the Fusion metadata registry. It is available in our website. And anybody want to see, the link is given here. So this another tool what we have developed for the bank. So from the bank side, they have to create a data level element repository. From the repository, the tool will pick up the data using the, convert the data from the granular. Actually, there is a infrastructure is already built, put in place because we are given guidelines to the banks in 2019. There is a server, the automated data flow server. So the granular level data will be captured in that server, and then automatically data has to flow to the next level. So there we have given the standardization. Accordingly, they created their repository, and then they convert to XML. Then next step, it will be filed or either through the system or through the manual filing. So this is the facility we are given to the banks. And we have started these projects. It's a collection perspective because the dissemination level we already achieved because the journey we started from 2023, 24, and 25. We have achieved the data, all the macroeconomic data we are converted into XDMX format is available for dissemination is already available. Now the XDMX based data collection, that is what I was referring. So you started a pilot projects in the 2024 we were initiated, and with the start, we started with the 4 regulatory entities. And there are XDMX is the backbone for this transition, and the ultimately it should improve the overall efficiency of the reporting entities and the regulated by reducing the reporting burden. This is one of the objective of the element-based reporting by adopting the XDMX as a tool, and it will provide a foundation for the RBI to build more data quality framework because there are different dimensions, as you know, the data quality. So we can even access the data quality of the data, improve the overall efficiency. So this is the overall intention of Reserve Bank. And so this is the high-level architecture. We are providing the metadata to the banks, and bank has supposed to generate their SDMX data flow, and they are transmitting to the RBI data warehouse, and we are processing, and we are given generating report. There are 2 sets of we disseminate internal data and for the public. So all these are happening through the centralized information management system. I forgot to inform you because there is a system we recently developed in the year 2024. We inaugurated this new system because an integrated platform for the data collection, data dissemination, data processing. So everything in a single system. So we integrated everything and put it together. We call it a centralized information management system. Yeah, this is already mentioned. This is a SDMX manager. This is the central hub, and from there we metadata hub, and we defined all the metadata, and this including data structure, dimension, and code list. It has interfaced the Fusion metadata registry. So indeed, this is everybody knows in the XDMS community what it. So now some of the development I will just highlight. So we intended to cover around 90% of the banking business in India because so we have provided all the requisite information to the banks, and they are in the process of developing their own. There are certain changes because they have to come up with the infrastructure. Infrastructure is, I mean, there is no infrastructure is required, but they have to do some changes because they are already capturing the information which is needed for generating the reports. So they need to do some kind of tuning at their level. So that process is going on. It was quite successful. Many banks have done that. So now we are in a very confident position to execute this. So our plan was to execute in a pilot basis. I mean, in a phased manner. So probably the first phase we are targeting by December of this year. And very newly, when yesterday we were discussing about the NLQ tools and AI based, so we are all because we made the foundation because SDMX is the backbone. So we made the foundation. Our system also SDMX with AI ready. So we are also planning to experiment with the AI NLQ tools, the natural language processing to this system. Thank you very much.
Thank you, Sujesh. That was very efficient, rich, and dense. So we stay in a central bank now. Moving to Indonesia, we'll talk about using SDMX in the context of quality assurance process. So I'm going to give the floor to, apologies if I don't pronounce your name very well, Sri Pujilistari and Mr. Koiru.
Yes.
You can correct my,
Okay.
the way I pronounce your name. So the floor is yours.
Thank you. Good afternoon, everyone. Thank you for giving us this opportunity to share this work. My name is Muhammad Hairul Hidayat. I'm here with my colleague, Ms. Sri Pujilistari. We are pleased to present our project titled Advancing Statistical Quality Assurance with SDMX, a metadata-driven approach from consistency check to smarter dissemination in Bank Indonesia. I would also like to acknowledge another author of this work, Ms. Anggraini Wijanarti, Ms. Shandani, Mr. Ahmad Zaki, and Mr. Insan. Okay. Here's the outline, and there are 4 sections here. We will begin with the background. To begin with, let us set the context of our initiative. The strategic environment of Bank Indonesia is undergoing significant transformation, driving the demand for the data is more agile, comprehensive, granular, and collaborative, while ensuring proper governance as well. And we believe this phenomenon is not only happening in Bank Indonesia, but also in other institutions across the country. And on the legal basis, of course, we do the regulatory reform. And for our transformation program, we aim to establish cutting-edge digital transformation supported by integrated data information. To achieve that, of course, we need to digitalize our statistical business process. Here is the overview of our statistical transformation, guided by our data policy, promoting one input, one process, and 2 multi-purposes, and implementing the end-to-end digitalization encompass entire statistical business process, start from the data collection, and then input integration data to our Omni intelligent platform, and then digitalized processing, and also the digitalized of dissemination. And for the underpinning the all of the process, we do the strengthening of overarching activities, which is involve revisiting statistical business process, and of course we highlight in here metadata management and data quality assurance. So to enhance our overarching activities, one is we expect in the end step, we expect we will advance metadata management through the 3 key principles. First is metadata first approach, and then ensuring comprehensive and standardized metadata, and also integrated the metadata within our system to interoperability and integrated. However, at this point, we have to be honest that our current state, we feel that standardized is not fully implemented. So this is the reason why we initiate this pilot project to adopting the SDMX to build a metadata-driven quality assurance. So why do we need quality assurance? As you can see on the left side, we have Bank Indonesia manage more than the 50 statistical product and over the 1,000 indicator across the macroeconomic sector. To give you a sense, maybe one of our publication is Indonesia Economic and Financial Statistic, or we call SECI. More than 100 tables and attract over the 30,000 views per month. And also in regional, more depth from the national level, we have a 34 province and with disseminate more than 200 tables. And other key products, including the financial system statistic and also the payment system statistic, which is wide coverage. We need to ensure the data quality, consistency, and also reliability before we publish to public. So that's why we have a pilot project, and we choose SECDA or regional economic financial statistic because there are so many tables there. We need to ensure the quality of each. So the process involved 4 stages. First is we prepare the concept scheme and code list based on SDMX, but we adjust to meet our needs, which is why we call that SDMX-like rather than a fully implemented SDMX. And we define the key rules, inter-table check, before and after, and also the inter-table, compare data between the related tables, since we disseminate several tables in each province. with the different filter dimension and also with the same aggregate concept. So their consistency need to be verified. And also we do the automation with the Python's programming and job scheduler, and with the Power BI, we do develop the dashboard for the key area report. And for the execution, we finally running automatically with the job scheduler. And then how did it turn out? It will be present with Mr. Sri Pujilastari.
Okay, good afternoon, everyone. I will to continue this presentation. On this slide, we highlight the significant advantages of our new Python and SDMX-based approach compared to the traditional macro method. As you can see in the new system, over more than 93% improvement in processing time and provide for greater efficiency, flexibility, and scalability. For the macro Excel, need 3 days for processing time, and then efficiency declines as data or complexity grows, and then limited flexibility, hard to enforce standards across multiple files or user, and then basic integration. But with the Python and SDMX, just need 5 hours for processing time, high efficiency, highly flexible, follow SDMX standards, and high potential for interoperability. For the next, moving forward, or our next pilot project, which focuses on leveraging SDMX together with AI-driven visualization. The primary goal is to make statistics not only consistent and standardized, but also accessibility, interactive, and actionable. For the on this top diagram, framework illustrate which is our end state framework on the end-to-end process of statistical product analyze and disseminate. For the begin on the left with our statistical product, which undergo metadata driven processing that might based on metadata structure. And then the outputs are stored in a statistical database where we prepare multi-format output using dynamic templates. Moving further, the result fit into the analyze stage where statistical report, narrative, and insight are generated. And then the dissemination channels through in internal and external platform. Finally, the dissemination channel support various format. Okay. And then in the lower section on this slide, you can see the workflow of an AI-driven chatbot with represent our innovation in user interactive. Chatbot integrate to component database conversation and question conversation. For the database side, statistical analyze, statistical data, analyze report, and metadata are first convert into vector embedding. And then on the question side, user queries and are also converted into vector using natural language processing or a large language model. Which vector are matched to a similarity method, enabling the system to retrieve the most relevant statistic information. The retrieved information is then combined with a prompt template. And finally, the response is generated by a large language model, ensuring the answer is not only accurate, but also human-like and easy to understand. And then the last slide, conclusion and future work. Okay. Implementation of the three principles, the metadata first, comprehensive and standardized metadata, and integrated metadata. And then by adopting an SDMX-like standard to build metadata-driven QA tools, Bank Indonesia has reduced processing time from 3 working days to less than 5 hours. And then the development of AI-driven visualization platform support by SDMX. And then the future develop and then a future work development of data quality to include plausibility checks such as utilizing machine learning techniques for anomaly or outlier detection. And then extending output metadata standardized and developing QA rules directly aligned with metadata structure for other statistical publication. There be strengthened cross-publication interoperability. And the last, developing AI and SDMX-based chatbot will you standardize metadata publication to provide interactive access, enabling user to visualize and navigate statistical output more intuitively. Thank you.
Thank you very much for sharing so much information, not just on what is being done at Bank Indonesia, but also how it's being done. You all have the slides that you're, of course, invited to study in detail. Without transition, I'm going to give the floor to Marco Wilpsar. The presentation was supposed to be made by J.R. Edding, who could not be here today. So thanks, Marco, for stepping in, who is going to talk about some modernization work of data dissemination at CBS Netherlands.
All right, thank you. And thank you for having us here. As you can see, I'm going to try to take you along a little bit on our journey to implement SDMX and .stat in our organization. As you can see, we are still sort of in the harbor, so safe space. People watching us, this represents both people internally in the organization, but also our partners that we provide a platform for with our current platform. And of course, there's the general public out there that is very interested in our figures, and they also need to be addressed, of course, with this implementation. Right. I didn't prepare an agenda here, but I'm going to talk you through a little bit of context. Where are we coming from? I'll focus a bit more on the organizational aspects, on the governance that is also quite important to have in place. And I will talk a little bit about tooling and the gaps that we identified in the tool sets that we put in place now, and we are in the progress of we are in trying to fill those gaps by several initiatives. I'll come to that. So to provide a bit of context, we are talking about 6,500 data sets across about 20 statistical domains, and our current platform is called Statline. It was developed in the 90s, way before I joined Statistical Netherlands. I joined only last year. Today this platform is end of life, and we are facing more and more difficulties to keep it up and running. So that and that was known for a few years already. So about 2, 3, or 4 years already, and actually way before people in the organization started to follow developments with SDMX. Then in the past 3 years or so, some more research was put into this, and then that led up to a decision mid 2024 to both adopt SDMX as the standard, and then as an additional decision to go with the FMR and .stat suite as our tooling to make this happen. Our legacy, so we're talking about, as I said, about 6,500 data sets or tables. We have both about 1,500 of them are what we call them are alive tables, right? So these are the tables that are regularly updated with new data. We have lots of archive tables as well, and as you can see, also varying sizes. Most of them are quite small, but we also have some tables that are up to 1 billion data points. I think relatively large amount of rather big tables in our databases. About 300 are above, I think, 40, 50 million data points. And I'll come back to that because that caused some technical issues. So what did we do? After this decision was taken to go for SDMX and .stat, we started a program in October last year. Quite ambitious, actually. We thought we would be able to migrate and go live in a year. Now we are about a year further and we did not go live yet. So definitely some lessons learned and some challenges on our way. We started with representation in a core team, representation of all the statistical departments, but also our communication department is represented. We got technical representation, obviously. I'm working for business analysis and process modeling part of the organization. And yeah, also then to illustrate the importance for the organization, the steering group for our program consists of the directors of the 5 main divisions in the organization. Yeah, so because our current system is kind of technically out end of life, we focus a lot on automated migration, and actually that went quite well, except for one thing. It really tested the technical boundaries of the .stat platform. So the main lesson learned there, yes, you can automate your migration. However, you do need to pay some attention to building in some quality in the results. What we actually did, we took every single table and created a set of artifacts for that single table. So you can imagine you end up with a lot of duplication in your system, and that caused the stress in the system in the end. Yeah, so apart from doing the technical stuff, we also put some effort in building a team to build the knowledge in the organization. So we have a very small team in the department where I'm working that is focusing on the SDMX. And yeah, we are developing training courses, and then we're a member of a wider support team. So that's more decentralized, because we think it's really important to have SDMX knowledge and modeling knowledge in the statistical departments, because in the end there is the domain knowledge on the tables that they develop, and that is, we think, quite important in their modeling effort. Yeah, some of the lessons learned compared to our current system. We already see that we will need far less people for designing tables, so that is I think that's good to see. Also already many times mentioned here, the need for harmonization, standardization of your code list, especially, and the concepts in your concept scheme, that is well recognized also within our organization. Yeah, let me move on. A little bit about governance. So there's 2 things about it, I think, to mention here. So we did a redesign of our dissemination process, and the process and all its of its supporting tools obviously needs some governance. You need to handle, when the process needs to change, of course, you need funding for maintaining your tooling, etc. So that's one thing. But then when you talk about the data, especially then these code lists and concepts, yeah, we say this is actually not SDMX specific. This is, you need to do this whatever standard you use, right? Because this is about the definitions of your data in your organization, all the way from your import of your data towards your output, your dissemination of it. Your whole organization will benefit from harmonizing those concepts and code lists. So we, with regards to the data, we say, well, we do use this reference framework for governance from the SDMX community, but we tie this in, or we connect this actually to our organization-wide data strategy with regards to data governance. Then also we identified a couple of gaps that we need to fill. Because, as I was mentioning in the beginning, our existing tooling start line is well supported with also all kinds of additional tools to support the whole process, to do all kinds of validations, etc., etc. Moving to .start, not everything is in there, but of course the internal user expects the same level of support. So first of all, we identified, and I'm only going to highlight the 3 of them, a tool to support the workflow and the process. So things to initiate a new table or do a major change, or to capture all the approvals. That's the kind of functionality we look for in this tool. Then, as was mentioned actually earlier today by the colleagues of the World Bank, we also identified the need for a metadata management tool, because we recognize that the people that are typically going to provide this referential metadata are not the most technical savvy people in the organization. And well, I can tell you from my own experience, it is a bit of a technical experience to create that SDMX CSV file that contains the reference data. So, and we take that away with this metadata management tool. And then the last thing I want to mention about this is a more advanced functionality for maintaining and managing concepts and concept schemes. We do have another application in the organization to manage our code list. But we do not have a similar thing for our concepts and concept schemes. Now, of course, we do use FMR as a registry for all of that. But one of the ideas we have, preparing the organization to move from SDMX 2.1 to 3, you could already start modeling your measures as concepts, and then for using them in SDMX 2.1, you can automatically, or you provide functionality to create code lists out of these concepts. And then, of course, when you migrate to SDMX 3.0 or beyond, then you do not need to remodel all of your measures again. Some additional tooling, but you can look them up in the slides that will be shared later. To conclude, so we did have some issues with performance, especially because of the size of our data sets, because of the high number of duplication of artifacts. So we did recognize that as a problem, and we started to build in some quality, reducing the number of artifacts that we need for every table. We did some testing with the to be released SDMX API, which looks promising. So that provided the program with a perspective to move on. Let me end with saying that we established a support team. We established a technical team to support the whole technical infrastructure, and there's still a way to go, but we think that we'll towards the end of the year we will be in a let's say a bit of a safe harbor, and we know that we can go on and implement this and go live next year. Thank you for that.
Thank you very much, Marco, for this honest reporting on your challenge and for mentioning that I think you're the first one who have managed to reach the limit of .stat. So I'm sure that Jens and Eric here have probably already addressed that. That's the beauty of having a lot of people using a tool like that. It will keep for sure improving constantly. The next speaker will talk about VTL. I heard yesterday that there was a lot of interest in VTL, so the next 2 presentations will actually be related to it. So this is Glenn Tice from BIS and Antonio Oleros, who are going to talk about simple, scalable, and agile VTL execution using FMR and open source Python package. Floor is yours.
Yeah, perfect. Thank you. So yes, as builds, then we're going to look at this question of how we can improve business processes, and specifically about VTL execution, and specifically how we can make it a bit more simple, scalable, and agile using some open source tools. So immediately I'm going to hand over to Antonio to kick us off. Antonio, please.
Thank you, Glenn. Good afternoon. I want to start actually by taking a question from yesterday. It was from this area. I don't know whether people have changed, but it's your question, okay. Which was whether it was VTL was production ready, right? I think it is a relevant question. I have a clear answer. Yes, it is. Or some products, right, for VTL are production ready. But I think that the message we want to share today is that it's beyond there. Because VTL being production ready means that an institution can use it and can use it effectively, right? But the nice thing about VTL is that it also makes the statistical process simpler for other institutions, right? So a lot of the institutions that are around share the same characteristic, right? That is that you have stakeholders. You have people, you collect information from other organizations. And this is what VTL is simplifying a lot, especially now when there are mature open source tools. And this is what we are going to present. I'm going to go with the simple part, and then Glenn will deal with the scalable and agile. So I love talking about VTL, but today, unfortunately, I'm not able. I'm just able to say that because we don't have time. So I'm just able to say that VTL provides a powerful language for data validation and transformation. You'll have to take my word on this, but I'm very happy to discuss this if you want. But that's not enough. If we only had VTL, like we have had for some time, we would be missing something, and it is about tools. And now we have some tools, some commercial tools, but we also have some open source solutions. Right? And what we are going to show is that by using this combination of 3 tools, 2 Python libraries, the VTL engine and PySDMX, and the Fusion metadata registry, we are able to deal very effectively with the VTL. So I'm going to show some code, but we believe this is so simple that it is not going to be problematic. Even if you have never used Python, I think you will be able to understand what we have to say. The Python VTL engine, this is one of the open source libraries. What it's doing is making it easier to execute VTL, okay? First, we have to say something like, we want to use the VTL engine, right? And basically, when we want to run VTL, we need 2 things. We need the script that we want to run and the input data, right? This is VTL. This is a very simple thing. The only thing it's saying is take one data set that is called DS1 and multiply it times 10, right? The second thing we need is the data. And this being an SDMX conference, I guess it's not a surprise to anyone that for data we need 2 things. We need the data structure and we need the data points, right? Originally, we support some format in the VTL engine library that you can write the data structures and the data points, okay? And the only thing we have to do is run this script with this input data, right? I think it is simple enough. And what we are getting as output as of today is pandas data frames, right? That is the result of executing any kind of VTL, not only this simple one, but also more complex VTL, okay? But there are a couple of things wrong here, and I'm going to go for the first one. You see there's no SDMX around, right? Which somehow it means that we are duplicating efforts, because most likely we have the data structures and we have the data points already in SDMX. That's the good thing. VTL engine is now SDMX native. That someone said this morning that it was a new word. We had it before, so. And this is the case because we also have PySDMX. And PySDMX and VTL engine, they work very well together, okay? We can use it, of course, PySDMX for both data and metadata. So now what we will have is, okay, the VTL engine, PySDMX, we have the script, but now we can link to SDMX REST API for data and metadata, and we can run based on the SDMX part. Okay? And we will get still the results. And I will leave the floor now to Glenn to see how this can scale.
Perfect. So yes, absolutely. This whole package of PySDMX and VTL engines makes the whole process of executing VTL now really simple. I mean, as you see, it's literally just one line of code, run VTL or run SDMX. But I guess for production use cases, we need something more. And specifically, we need a way to package and distribute VTL. And actually, we already have some good ways to do that. And in fact, the SDMX information model, if you sort of delve into the depths of it, actually has this thing called a transformation scheme. I think it was mentioned possibly one or two times in sort of previous presentations, maybe yesterday. So these things are fairly sort of involved structures. But I think, there's really sort of one takeaway here, that a transformation scheme in SDMX is a VTL script, it's a VTL program. So if you remember that, forget about all of the complexity behind it. Transformation scheme is a VTL script. And the key innovation here is that this is now supported natively by SDMX and VTL engine. So it wasn't shown in the previous code, but you can do this. You can now pull a transformation scheme, in other words, a VTL script, directly from a registry or even from a file as a transformation scheme, and you can execute that directly. So that's really helpful. So that allows us to do sort of several things here, and particularly, of course, sort of packaging this together as packaging as a transformation scheme, and then using maybe FMR as the repository for this means the business logic can now be decoupled from the data processing mechanics, and it's this separation of concerns that actually makes the data operations more scalable. Particularly, of course, the business rules and data structures, these can now be reused across usage duplication, and importantly, actually promotes modular and composable data pipelines. So there's benefits here, both for sort of internal processes. So if you're working with data pipelines internally, then it improves that process by reducing this duplication and composable pipelines. But also with the external data collection use case as well, we have some real benefits there, because it means now that external data providers can now use VTL engine by SDMX, as we've just shown very simply, to carry out their programmatic checks using the data collectors, using your business rules before submission, and that guarantees integrity and also eliminates the propagation of bad data and the cost of fixing those errors sort of later on down the pipeline. And all of this sort of makes our processes nice and scalable. But there is more as well. And again, because the business logic is separated from the processing mechanics, these two can now evolve separately. And particularly and importantly, now business users can now properly take control of their business logics. It's no longer embedded in code within pipelines. And that means these things can iterate rapidly. Business users can change code lists. They can modify the data structures, etc., as need, without making any pipeline changes. And that relieves the burden on, of course, on IT specialists and data engineers, and I'm sure they're going to be all very pleased about that. And of course, the net effect of this is that we end up making the whole data operations more agile. So just to conclude, VTL engine democratizes VTL. SDMX, as Antonio showed, works very nicely with VTL engine. Now VTL work very nicely in the SDMX context. FMR productionizes the whole thing. We combine all these together, and then we end up with a really nice package for simple, scalable, and agile VTL execution. It's all open source as well. So that's all. Just one thing before we go. Check out the references in the slide deck when you get access to it. There's links to all the tools. And also a really nice, fully worked example that Antonio put together as a Jupyter notebook. So thanks so much, Adeep. That's all, folks.
Thank you very much for this very practical presentation. So if you don't know Python, I think it's time to start learning it. We probably have time for two or three burning questions. I want to be sure that we don't steal time from the presenters of the next round. So we're going to take two, three, not many more. So Abdullah, then we have running microphones.
Yeah.
Yeah. The other side, Abdullah.
Thank you. Thanks very much. My question is to Marco. Can you say a few words about the link between your production units and your dissemination units? How does the data flow? And if there are any plans to introduce any automation into that part as well, or there are no plans? Thank you.
Before you answer, we'll take the other question. Was there?
Yes.
And then there, and then, I mean, three questions. That's
Question
what we'll start
related
with.
to VTL. Okay, I'm not an expert of VTL, so maybe I haven't understood very well. But my dream is to receive for validation from the international organization where I have to report my data, a validation message. You mean this when I speak about transformation schema? So that under the transformation schema, there is an SDMX message with the validation rules. And in this case, could you please share somewhere example of this validation message compliant with the SDMX transformation schema? Thank you.
Then we had a third question, and then we'll have short answers.
I'm Vladimir for Unido Statistics, and I have a question to Reserve Bank of India, Sajesh. Yesterday you questioned about experience in training a model, and you got no answer. I see today that you are playing with AI models or LLMs, and do you have any experience with supervised fine-tuning and reinforcement fine-tuning of pre-trained LLM models?
Okay, thank you for the questions, Marco. Maybe you start,
Yeah.
then Glenn, and then Sujesh.
Yeah, thanks for the question. We believe that the ownership of the data, the content of the tables is really with the statistical departments. And so they own the table, they own the table design, but that is of course guided by SDMX guidelines, modeling guidelines, but as well as SDMX presentation guidelines for presenting or disseminating it through our output channels. So it's really an interaction between our communication department and the statistical divisions. Does that answer your question? Well, that's work in progress. So I think, well, I'm not working in this field for too long, but I think from what I've learned so far, in many organizations, the processing of the data from microdata all the way to the aggregates and the tables that we disseminate is usually with the statistical domains, and they maintain, in our organization, many of them maintain their own systems. So there is, with the establishment of the dissemination process and using SDMX, then of course the SDMX model, table model, provides the specification of the data that you need to provide to the system. And then we expect, but that's really for a phase 2 in the program, that we will see more automation in the processing from microdata towards this dissemination system. Yeah.
So the question you are asking, because yesterday I was asking this question because we have just started this project. We are not even, I mean, this is very nascent stage. Now we are ready with the AI. I mean, the SDMX backbone we have developed. So if we query anything, so from the SDMS dimension code list, data can be retrieved. But the question is like, suppose RBI or any of the central bank, so the public trust is very important. because the credibility. Suppose even ChatGPT, we have different AI tools. People can generally ask any number of questions, so they will give answer. But the question is like, suppose RBI or any institution publish a data through their data portal in a specific written format, so people have trust on it. But if you are asking through AI, if the answer is not exactly the answer what it is intended to be given, then there is a question of credibility. So how to train, how to convert this question into proper, how to code this question, convert into proper question, and the system, how the model has to identify. That is something challenging part. So that we need to address. So that's why I was asking question yesterday, if somebody has experience, how they trained. Yeah, that's all. Otherwise, we are on the very, very initial stage. So it's a learning process. Yeah, thank you.
So from the VTL part, yes, that's exactly it. And I would say it is even nicer, right? Because if you have an FMR instance, then it is there. You don't even have to provide anything. You can also check by references because there is a mapping, so you can even see any user that has access can check what are the transformation schemes related to this. So in practice, what are the validations that are related to this? So once you have it in FMR, it's public for everyone's consumption and everyone's execution, right? So that enables any stakeholder to run what you have written. And we have an example in our repository. It is used in the Jupyter notebooks that was in the resources, but we can share it with you.
Thank you. We're going to now to reboot the table here. Try to be efficient and do that in 1 minute. So thank you very much to the 4 teams. Any way you want. So that was very efficient. We're going to move to the next presentation, which is, again, about VTL. There seems to be much appetite for that. And Violeta Kalian, I don't know how you pronounce your name, sorry, from Statistics Island will present open source data validation, integrating SDMX, Python, again, VTL and machine learning. So, floor is yours.
Thank you. Oh, is it sound is good? Is the sound okay? Yes, this is, the title is a bit long, and I think when we gave this title to start with was just to remind ourselves what we want to do. So we were afraid to forget something and put all the things in it. I will not focus on VTL, but it's there and it plays a role. So this is the work of two very different people from Statistics Iceland. I'm a mathematical statistician and a methodologist. And my colleague Ragnhildur, she is an IT specialist, and she's much more knowledgeable than me about SDMX. But I was much more concerned about one of the processes that takes place in an official statistics institute, which is data validation, and which we think should take place in many places throughout production. So it should not take place once when you get your data or once when you deliver your data, but it should take place in many steps throughout the whole process from the start to the end. And this was our goal, to do open source implementation. We are a small institute and we use open source as much as possible. So knowledge that others share, and we like to share what we can do also with the others.